In this video, we're going to apply trigonometric substitution to solve a definite integral. Here we have integral from 0 to a x squared times root of a squared minus x squared dx. A is just a constant. We will assume that a is larger than 0. Alright, so we have root of a squared minus x squared. That is constant squared minus variable squared. So we will make the transformation x is equal to a sine theta. That is a trig substitution we'll be applying. Differentiate both sides, we get dx is equal to a cos theta d theta. Derivative of sine is cosine. So the integrand is x squared, root of a squared minus x squared. Let's substitute x in, and we will get a sine theta all squared times root of a squared minus x squared, that's going to be a sine theta all squared. Simplifying this, we get a squared sine squared theta. Let's factor out the a squared from inside the radical. We get a squared times 1 minus sine squared theta. And that gives us root of a squared is just a, so we get a cubed sine squared theta. And this is where the trig identity comes in. Cos squared theta plus sine squared theta is equal to 1. So 1 minus sine squared theta is cosine squared theta. So we get root of cos squared theta. But root of cos squared theta is just going to be absolute value of cos theta. So we get a cubed sine squared theta, absolute value of cos theta. But because of the way we restrict the angle theta, we can just drop the absolute value and write it as a cubed sine squared theta times cosine theta. Now we also have to change the limits. So we have x equals 0. This is going to get plugged into theta is equal to sine minus 1 of x over a. And that gives us theta is equal to sine minus 1 of 0 over a, which is just 0. What is sine minus 1 of 0? That's saying what is the angle whose sine is 0? Clearly that is just 0. The upper limit, x is equal to a. Plug that into theta. Theta is equal to sine minus 1 of x over a. Substitute x equals a, and we get theta is equal to sine minus 1 of a over a, which is 1. What is sine minus 1 of 1? That is saying what is the angle whose sine is 1? The answer is pi over 2. So what we have shown is that the integral from 0 to a x squared times root of a squared minus x squared dx, after applying a trig substitution x equals a sine theta and also changing limits, we have integral from 0 to pi over 2 a cubed times sine squared theta cos theta times a cos theta d theta. So now the goal is to solve this trig integral and then use some trig identities to bring the answer back to x. So let's simplify this. What do we get? Well, we have a cubed times a. That's going to give us a to the fourth. We have sine squared theta. And we have cos theta times cos theta. That gives us cos squared theta d theta. All right, so the limits are from 0 to pi over 2. Okay, how do we go about solving this? Well, we can rewrite this as a to the fourth, integral from 0 to pi over 2. Let's rewrite this as sine theta times cos theta all squared, integrated with respect to theta. Now we're going to apply a double angle identity, sine 2 theta is equal to 2 sine theta cos theta, which means that sine theta cos theta, if you divide both sides by 2, sine theta cos theta would be sine 2 theta divided by 2. So what we have is a to the fourth, integral from 0 to pi over 2, sine theta cos theta all squared d theta. That's a to the fourth, integral from 0 to pi over 2, sine 2 theta all over 2 all squared d theta. So we get a to the fourth divided by 4, and simplifying the integrand, integral from 0 to pi over 2 sine squared of 2 theta d theta. Now we have to use another trig identity, sine squared theta. Sine squared theta is 1/2 1 minus cosine 2 theta. But that's not what we have. We have sine squared 2 theta. So notice the 2-to-1 relationship. When this is theta, this is 2 theta. So sine squared 2 theta will be equal to 1/2 1 minus cosine 4 theta. Alright, so what we have is a to the fourth over 4, integral from 0 to pi over 2, and sine squared 2 theta, that can be expressed as 1/2 times 1 minus cosine 4 theta, integrated with respect to theta. Alright, so what we have is integral from 0 to a, x squared times root of a squared minus x squared is equal to a to the fourth over 4 times integral from 0 to pi over 2 sine squared 2 theta d theta. And we use the trig identity to simplify this to a to the fourth over 4, integral from 0 to pi over 2 times 1/2 1 minus cosine 4 theta d theta. And this part is just sine squared 2 theta. So now let's remove the 1/2 outside the integral. We get a to the fourth over 8, integral from 0 to pi over 2 times 1 minus cosine 4 theta d theta. And integrating this term by term, we get a to the fourth over 8. What is the integral of 1 with respect to theta? Well, that's just theta. What is the integral of cosine 4 theta with respect to theta? Integral of cos theta is sine theta, but we have integral of cosine 4 theta. So we have to apply U substitution, but because it's easy, we'll do that in our head. So integral of cos theta, cosine 4 theta will be sine of 4 theta divided by 4. And that's just reversing the chain rule, or U substitution. And let's not forget the limits. Lower limit is 0, upper limit is pi over 2. Now we can apply fundamental theorem of calculus and plug these limits in. So we get a to the fourth over 8 times, the upper limit is pi over 2 minus sine of 4 times pi over 2, which is sine of 2 pi, divided by 4, minus, and now let's put the lower limit. The lower limit is 0, theta is 0, minus sine of 0 over 4. Sine of 0 is just 0. Sine 0 is 0. Sine of any multiple of pi is 0. So if we simplify this, we're going to get a to the fourth over 8 times pi over 2 minus 0, and minus times minus is plus, plus 0. So when it's all simplified, we get pi a to the fourth over 16. This is the answer to this definite integral, integral from 0 to a, x squared, root of a squared minus x squared dx. All right, let's review some of the identities that we've applied. So one of the first identities that we applied was sine squared theta plus cos squared theta is equal to 1. And we use this a lot when we do trig substitution. So this was the first one. The second identity was sine 2 theta, the double angle identity. Sine 2 theta is 2 sine theta cos theta. Then we also applied sine squared theta is 1/2 1 minus cosine 2 theta. But notice the 2-to-1 relationship. This is very important. When we have theta, we have 2 theta here. So when we solved this integral and we came up with a trig integral that has sine squared 2 theta, that means we have to have 4 theta here. All right, we also did a U substitution, but because it was easy, we just did it mentally. But just to go through the steps, integral of cosine 4 theta, we're letting this part be U. So U is equal to 4 theta. du, take the derivative, du is 4 d theta, and divide both sides by 4, we get d theta is du over 4. So this 4 is exactly the reason why we have 4 here. That's just from a U substitution. All right, thanks.